Hello everyone, welcome back to the session on surface tension and viscosity. I am Rahul, Assistant Professor of Physics, GVPP, Government First Grade College, Hagaribommanhalli. In the previous session, we discussed about excess of pressure inside a liquid drop. Continuing our discussion, in this session, we will discuss topics like angle of contact and capillarity. Let us begin. Angle of contact. As the name suggests, angle of contact gives us how a liquid settles down on the solid surface, or when the liquid is put on a solid surface, how it sits on that solid surface. Let us consider these two pictures here. We have considered two different liquids. One is shaped like this and second one is shaped like this. For example, we can consider the two liquids here be water and mercury. Water makes a shape when it is put on the solid surface like this. But however, when you put the mercury, which is also a liquid, it makes a different shape when compared to water. This makes mercury makes a shape similar to this. How do we define angle of contact? Angle of contact is defined as it is the angle between the tangent to the liquid surface at the point of contact with the solid surface inside the liquid is called as angle of contact. So see here, to know the angle of contact, we have to first draw the tangent to the liquid surface. Okay, where we have to draw this tangent? It should be at the point of contact with the solid surface. See here from the picture, this liquid drop is making contact with the solid surface at 2 points, here and here. So what we can do is we can draw tangents at these 2 points. First tangent will be like this and second one tangent will be like this, because the tangent must be to the liquid surface. Okay, so tangent to the liquid surface at the point of contact with the solid surface. Then the angle where we should consider the angle, it should be inside the liquid. So inside the liquid angle will be like this, and for this contact point the angle will be like this. These two will be the angle of contact for this liquid on the solid surface. Now if you consider this second drop here, here also the water touches the liquid touches the solid surface at this point and it also touches the liquid at this point. So at this point of contact we have to draw the tangent to the liquid surface, either like this or like this. Now the angle of this tangent to the solid surface, where the angle should lie, it should lie inside the liquid. So theta will be like this. Now when you consider both these two images, for the first image the angle of contact is less than 90 degree, that is acute angle, and for the second image the angle of contact is more than 90 degree, that is absolute angle. Now why angle of contact is important? Let us consider two scenarios where a glass plate is dipped into a beaker containing water, and in second scenario the same glass plate is dipped into a beaker but containing mercury. Now what happens in these two cases? What will be the angle of contact? We have to learn. For water, we observe that some of the water molecules has risen above their normal level and cling on to the glass plate. And for mercury, some of the mercury molecules have dropped to compared to their normal level and have depressed and made contact with the glass plate. That is, for water like this, the molecules will be cling on above their levels. But however, for mercury, if this is the normal level, then the mercury molecules will be dipped lower like this and like this. Now, this change in contact angle between the glass plate and the liquid is because of the difference in angle of contact made by these two liquids onto the glass plates. Now, if you want to find out the angle of contact, what we have to do? We have to draw a tangent. For this, the tangent will be like this, okay? And for mercury, the tangent will be drawn like this. Since the angle of contact is inside the liquid, theta will be here, and for mercury, theta will be here. You can observe that the angle is acute for glass and water, where the angle of contact is absolute for mercury and glass plate. This different angle of contact can be observed when we do this experiment. We know that the angle of contact varies from 0 degree to up to maximum of 180 degrees. If the angle of contact of a liquid is acute, that is less than 90 degree, for example, water and glass, the angle of contact between glass and water is acute, as you can see here. Now this is less than 90 degree. Now these type of liquids are called as wettable liquids. That means the liquids whose angle of contact is less than 90 degree, that is acute angle, those are all liquids comes under wettable liquids. When you touch these liquids, you feel wetness. That is, when you touch water, you feel water wetness, right? So that is called as, that is because the angle of contact for water is less than 90 degree. But however, if the angle of contact is absolute, that is more than 90 degree, for example, mercury here. So this is more than 90 degree. Now for these liquids are called as non-wettable liquids. When you touch these type of liquids where the angle of contact is more than 90 degree, these do not get you wet. That means you will not feel wet when you touch these type of liquids. That is, for example, mercury is the one of the example for non-wettable liquids, and water is the example for wettable liquids. Now, the angle of contact depends on following factor: the nature of the liquid and solid. That is, which type of liquid we have taken and what is the solid surface that liquid is present. The nature of these two substances will play a major role in determining what is the angle of contact. For example, the angle of contact between water and glass is different from angle of contact between oil and wood. Here both the nature of all the materials will play an important role in determining the angle of contact. And for another example, if we consider pure water and clean glass, the angle of contact is almost zero. That means when you take pure water and put it on a clean glass, the water will spread out throughout, almost making the angle of contact zero. And the second factor on which the angle of contact depends is the medium which exists above the free surface of the liquid. For example, let us consider the mercury which is on a glass plate. The angle of contact between mercury and glass plate is different when the air is above the mercury and when instead of air there is water layer above the mercury. That is, the angle of contact between the mercury and glass is different to the angle of contact when there is a layer of water which exists above the mercury. So that completes about angle of contact. Moving on, next concept is capillarity. As you can see from the image here, we have three capillary tubes. What are the capillary tubes? These are the tubes with fine bore. Now bore is nothing but a hole which is spread throughout its length. Okay. Now when the capillary tube like this is dipped into a water beaker as shown in the figure A, you can observe that when you dip the capillary tube inside the water like this, the water rises above inside the capillary tube and it sits above the normal water level inside the beaker. And if you do the same experiment, but instead of water you take mercury and dip the capillary tube into the mercury, you observe that the mercury level has dropped inside the capillary tube compared to the beaker's mercury level. So what happens is this liquid will either rise or go down depending on the property of the liquid inside a capillary tube. This property of rise and depression of a liquid inside a capillary tube is called capillarity. So capillarity nothing but it deals with the physical property of the liquid to rise or to depress inside a capillary tube. Capillarity is the ability of the liquid to flow in a narrow space such as capillary tubes. And this flow in the capillary tube does not depend on the external forces. Okay, for example, gravity does not determine whether the liquid comes down in a capillary tube, and this happens only because of the cohesive force as well as adhesive forces acting between the molecules. What are the cohesive forces? These are the attractive force between the like molecules. For example, if you take a capillary tube and dip it into the water, the attraction between the water molecules are the cohesive forces, and the attraction between the glass molecules of the capillary tube and the water molecules, that is the adhesive forces. If the adhesive force between the liquid and the solid surface is stronger than the cohesive force, okay, that means for example glass and water, here what happens, the attraction force between the glass molecules and water is larger compared to attraction force between the water and water, so adhesive force will be a stronger force in case of glass and water. In this case, since adhesive force is greater, what happens is water molecules climb above to the capillary tube and rests above the normal water level of the beaker. And this phenomena is entirely called as wetting. Okay, wetness, which provides wetness, that is wetting. So, for example, water in the glass capillary tube. Wetting takes place when the adhesive force are greater compared to the cohesive forces. On the other hand, if the cohesive forces is stronger, that is the attraction force between the like molecules. For example, if you take a capillary tube and dip it into a mercury liquid, for mercury the cohesive force is stronger, that is force of attraction between the mercury molecules is itself stronger compared to the force of attraction between the glass of the capillary tube and the mercury molecules. Hence here cohesive force will be stronger compared to the adhesive forces, and this will cause the liquid to be depressed because the obviously the mercury molecules will attract more of the mercury liquid towards itself. Hence inside the capillary tube the molecules does not rise and instead they will get depressed and forms a convex meniscus. So that completes capillarity. So in this session we discussed about angle of contact as well as capillarity. We will end this session here itself and moving on to the next session. Thank you.